All right, here's an example of using Charles's law to solve this gas question. When you look at the question, and when you do any of these questions, what I'm having you do is use this large formula here. So it's P1 V1 over N1 T1 equals P2 V2 over N2 T2. Now sometimes you have to use all of the variables, sometimes you only have to use a couple. So the formula that you wind up using will depend on what they give you. So in the question they give you a volume, so I wrote that down as volume 1, and then they give you a temperature, and that would be the temperature 1 right there. And then they gave me a second volume right there, and then they ask for the new temperature or temperature 2. Notice that they don't, or they say somewhere, assume the pressure and the number of moles stay the same. So that means the pressure and the moles are a washout, that I don't need to use those in my formula. So pressure I don't need to use, and moles I don't need to use. So I'm just going to cancel those out. So my formula turns out to be V1 over T1 equals V2 over T2. So now I plug those numbers in. Oh, just before plugging in, notice with the temperature here that I converted the temperature into Kelvin. So you have to take any, to get a Kelvin temperature, take whatever your Celsius degrees is and add to it 273.15. Okay, so if I add the 21.3 and this, it should come out to that. Okay, so now I take these numbers, and what I need to do, I'm solving for T2. So here's my formula, and I'm solving for T2. So to solve for T2, I write T2 is equal to, and then I multiply the cross that doesn't include what I'm looking for. So this one here, so V2 times T1, divided by the thing that's across from what I'm looking for. You can do that mathematically, but all of our formulas that we're using, you can use that cross multiply and divide kind of thing. Okay, so here's the formula I'm going to use. So I plug in my V2, there it is right there. I plug in my T1, there it is right there, plugged in, and I plug in my V1, which is right there, put it there. The liters cancel, so now I just multiply the numbers and divide. I came up with this, and then I round it to however many sig figs that they have. So there's 3 sig figs there, 3 sig figs there, 3 sig figs there. So in my answer, I need to only give them 3 numbers. So those first 3, since this number here, the fourth one, is less than 5, then this 0 stays. So 6 were 0, and then I put a decimal at the end because it needs to have 3 sig figs. If I just wrote 640 with no decimal, this only has 2 sig figs. The 0 isn't significant. But by just putting that decimal there, right there, that tells you that the 0 is significant. So there's your 3 sig figs. Okay, so that's an example of using Charles's law.